This comes from section 5.7 and in 5.9. This will finish up our unit. The fundamental theorem of algebra. So we know how to find the degree of a polynomial, and if it's the degree is the highest exponent, and if it's in factored form, then we have to visualize multiplying it all out to find the highest exponent. So whatever that degree is, the fundamental theorem of algebra is the degree of a polynomial is exactly the number of solutions, is exactly the number of roots, exactly the number of solutions, and to f of x equals 0 if you consider single roots, double roots, and triple roots, which we haven't really talked about yet. So that's the fundamental theorem of algebra. It's summarized that the degree of a polynomial is exactly the number of solutions. Now, you might have duplicate answers. I mean, you know how you could factor, you could get x minus 1 times x minus 1? So it's like a duplicate, right? It'd be like x minus 1 squared. So that's a double root, and that counts as 2 answers. So when you factor it, so there's the fundamental theorem of algebra, and then I need to say something else. When you factor it, each factor of degree 1 is a single root. That's the most basic, and I won't write this sentence over and over. Each factor of degree 1 is a single root. Degree 2 is called a double root. They look different graphically, and I'll show you in a second. And if you have something repeated 3 times or raised to the 3rd power, that's called a triple root, and that looks different as well. And so we're just gonna focus on those different types of roots for graphing it. So that, so the triple root, the double root looks like it's tangent to the, it just bounces off or touches. So the double root is tangent. I'll show you in just a second with examples. The triple root flattens out, but it still passes through. Flattens out, just like y equals x cubed. And the single root just passes on through just like normal. Passes through the x-intercept like that. Passes through. The double root is tangent, the triple root flattens out. Alright, we're going to do at least 4 examples of this. So the directions we'll say, and we'll practice in just a second. Sketch. And this is without typing in it on your calculator. I want to know the shape. Okay, so here we go. Now, in order to do this, they have to be factored already, and you'll be given them in factored form. So let's say I have y equals x times x plus 1 times x minus 4. Okay, that's the problem. I just want to sketch it. You can do this without your graphing calculator. You can know the shape. So let's review. Let's talk about it for a second. What's the degree? Good. So I hear the degree is 3, right? Because if you distributed everything out, if you multiplied it all out, so that's good. So the degree is 3. So how many solutions are there? 3. Okay, the fundamental theorem of algebra. So the degree is 3, there's 3 solutions if I set it equal to 0. And then the roots are, the zeros are, which we'll put in our graph. Let's list them. What are they? -1 and 4 and 0. Nice. So 0, -1, and 4. And because each root only appears once, they're all single roots. So they're all single roots. Okay, so we're gonna sketch it. Your sketches will only have the x-axis. We don't really care about the y-axis. So we're gonna put 0 down because that's one of our, it passes through 0, it passes through -1, and it passes through 4. So put those x-intercepts down.
What do you mean by all?
Oh, okay, great. Thank you for asking. See how this is to the 1 power, this is to the 1 power, this is to the 1 power? The invisible exponent is a 1 on each term. Nothing is squared. So they're all single roots, yeah. Thank you. So how do I sketch this? This is where the end behavior comes in. So it's degree 3, so is it even or odd? It's odd. And does it have positive or negative orientation? What's the leading coefficient? Positive, right? There's positive. So all odd functions that have positive orientation start down and end up. Because that looks like y equals x cubed. Yeah, Floyd? Oh, that's gonna come in the next examples. For this example, we're just doing single roots. You're gonna see all of them in a second. So is everyone okay that it starts down and ends up? Okay. And now I'm ready to sketch it. I'm almost done. Because you know the end behavior, it goes like this. Watch this. Watch this. Boom. It goes through. It passes through, and it passes through, and that's the shape that my graph will have. Because it has to pass through the x-intercept for single roots, and that's the shape. Now, how high exactly is this maximum, or how low is the minimum? That's for calculus. So we just do a sketch. For now, what we could do is we'd have to plug a number into the table to figure out how high or how low. But for now, just a sketch. Okay, so next, let's look at some more examples with double roots and more things. So let's try 2 double roots. Let's go y equals x plus 1 squared times x minus 4 squared. Okay, we're going to sketch the shape. So let's write down all the information. What degree is this polynomial? Yeah, if you were to distribute everything out, it would be degree 4, right? X squared times x squared is x to 4. So it's even or odd? Even. And is it positive or negative orientation? Positive. So I know it starts. What's the end behavior? Starts up, ends up. So I'm just going to put little arrows like starts up and ends up. When I graph it, I know that it's just like y equals x squared. Awesome. Good, good, good. So, and what are the roots? What? -1 and 4. And are they single roots, double roots, or triple roots? They're both doubles. Yep. -1 and 4, and they're all double roots. And so a double root, it doesn't pass through, it bounces off. So it looks like this. Let's sketch it. So here's our x-axis. And we're going to plot -1 and 4, which happen to be our x-intercepts or roots or zeros. Those all mean the same thing. X-intercept, root, 0. And watch this. So you know you start up and you end up, okay? And this is what we're learning new today, is that it doesn't pass through. It bounces off its tangent. So it goes like this. So it's headed toward it, it just touches its tangent, and then it turns back around. Because it's a double root. That's what double roots do. And then here, it doesn't pass through its tangent, and it bounces off. So there's our shape. That's what it'll look like if you type it in on the calculator. So we don't know exactly what this local max is, but it doesn't matter. Just the direction and the shape is what's important. So let's try one. We'll do one more with the triple. We'll do one with like everything in it. And you guys, let's make it up together. So I'm gonna insist that we put a negative in front because that's different than we've done before. But what do you want? Let's do a single root. So give me the factor. Anything you want. 2. You want the root to be 2, so we'll do x minus 2 for our single root. Now we're gonna throw a double root And we're going to throw a triple root in. So what do you want this factor to be? X minus 1 and x plus what? X plus 5. Okay, great. Okay, so this has everything in it. Let's do this one together. So first, what's the degree of this guy?
3.
Okay, hang on a second. The whole polynomial, each factor has a degree, but the whole thing, if you multiplied it all out, what would the highest exponent be? 6. 3, 4, 5, 6. So it's an even, and the orientation is negative. So what's the end behavior?
Off goes down. Starts down and ends.
Starts down and ends down. Yep, that's gonna be, you can't sketch it without knowing that. It starts down and it ends down. Alright, so let's go ahead and put our roots on the number line. This is the x-axis. So we have 2, 1, and negative 5. So negative 5, 1, and 2. Just put them in, an approximately correct location. Negative 5, 1, and 2. And it starts down and ends down. So I'm going to put a down arrow here and a down arrow here. And now we just have to say, okay, does it go through it? Does it bounce off? Or does it flatten out? The triple root flattens out. This is what I mean. So as it heads towards negative 5, it passes through, but it flattens out and then continues, just like the graph of x cubed. That's what a triple root does. That's what I mean by flattens out. It goes through it, but it flattens out. And then we head toward 1. What kind of root is 1? Double. So do we pass through or do we bounce off? Bounce, bounce, bounce off. And then what kind of root is 2? Single, right? Because there's an invisible 1 exponent. It's a single root. So it just passes through, and it should make sense with your end behavior. If it doesn't match up with the end behavior, then that's a good check that you did something wrong.